Welcome to Crystal Clear Chemistry channel. In this video, we are going to discuss in detail about the JEE Advanced paper. Paper 1 Chemistry now discuss in this video. Directly I am getting into the section 1. In the section 1, there are 4 questions and each one carries plus 3 for the correct option and for the negative mark minus 1 for each question, right? So the first question, the heating of NH4NO2 at 60 to 70 degrees centigrade and NH4NO3 at 200 to 250 degrees centigrade, which is associated with the formation of nitrogen compound containing compounds X and Y. So when they heat sodium nitrite and nitrate, the compounds that are obtained are X and Y, and they are asking us to write what are X and Y here. So here, if we consider the NH4NO2, which is ammonium nitrite, on heating, it readily produces N2 plus 2H2O, whereas ammonium nitrate, NH4NO3, when it is heated, we readily get N2O, which is nothing but a laughing gas, nitrous oxide, along with the liberation of the two water molecules here. So the X and Y are N2 comma N2O, where the option A is correct. Second question, the correct order of the wavelength maxima of the adsorption band in the UV region for the given complexes. Here, if we observe the complexes, the ligand is differed and they are asking for the wavelength maxima. If the ligand strength is less, it absorbs more wavelength, right? In the spectrochemical series, Cn minus ion comes first, which is a stronger ligand when compared to NH3 and then H2O followed by Cl minus. According to this order, uh, and as the strength of the ligand is inversely proportional to the maximum wavelength adsorption, we can say the first option itself is the correct order of wavelength maximum, right? Now, let's move to the third one. One of the products formed from the reaction of potassium permanganate with iodide ion in a neutral aqueous medium is. So, if we consider the potassium permanganate ion, 2 moles of KMnO4, 2 KMnO4 when it reacts with iodide ion. Let us consider potassium iodide, and as it is aqueous medium, I am going to take H2O. Here in the case of aqueous medium, this KMnO4 readily converts into MnO2 that we know already. So 2 moles of MnO2, and here we get 2 moles of KOH also, along with the formation of KiO3, potassium iodate ion. Potassium iodate compound is formed, and we can say that iodate ion is formed. So the correct option is B. Next one. Consider the depicted hydrogen in the hydrocarbons given below. The most acidic hydrogen is. If we consider the most acidic hydrogen, this type of questions, what we need to check, if the given compound loses the H plus ion as it is acidic in nature, the one which readily forms most stable carbon ion, the one which readily forms most stable carbon ion is highly acidic in nature. That is the key point to check the option. Suppose if we consider the option B, and let's check this one as all are cyclopentadiene it contains. If we consider that particular conjugated system in the option B, after losing this proton, we will get a negative charge here. We will get a negative charge here, right? So I'm writing this again along with the methyl group. double bond, and here one methyl group is there, and this is CH3, where it loses H plus ion, so that it will convert into negative one, right? And in conjugation, if this minus charge comes here, the double bond will shift onto this carbon atom, so that immediately the ion gets aromaticity. The ion gets the aromaticity, right? And we know cyclopentadienyl anion is more stable because of that aromatic character. That is the reason why compound B is having that most acidic hydrogen. Next one. Let's see all the rules that how you get the full mass management, partial mass number. Now let's discuss the question. Regarding the molecular orbital energy levels for the homonuclear dynamic molecules, there are some characteristics. The first one, if we consider bond number of JEE2, as it is a loading gas, we know that they are the monoatomic gases. Hence, the bond order we can say that G. So it is the correct statement. What about the option B? The highest occupied molecular orbital of F2 is a sigma type. No, it's not sigma type. Suppose if we consider the configuration, F2 configuration, electron configuration, it is nothing but sigma 1 is to sigma star 1 is to sigma 2 is to sigma star 2 is to, and then sigma 2 p J2, pi 2 p x2, pi 2 p y2. So here if we consider uh, sigma 2 p J2, pi 2 p x2, pi 2 p y2, pi star 2 p x2, pi star 2 p y2. So H1 highest occupied molecular orbitals of pi type, but not the sigma type, right? So option B is the wrong statement, incorrect statement. And what about the C? The bond order of O2 plus is smaller than that of bond energy of O2, not the bond energy. Okay, they are comparing the bond energies for O2 plus and O2. If we calculate for O2 plus, we will get 2.5 as the bond order, whereas for O2 bond order is 2. So it is in fact greater than O2. So option C also incorrect. What about D? In the case of option D, the bond length Ni2 is larger than that of the bond length in the B2. So if we consider the bond lengths, as both are having the same bond order, Li2 and the B2 as one bond order 1, we can say that the Li2 bond order is not greater than that of B2. Hence, the wrong statements are both B and C, and but to choose the answer as B or C. The pairs of diamagnetic ions are, if we consider La plus 3, lanthanum La plus 3 ion, the configuration is Xe4F0. And similarly, Ca plus 4 also, if we consider, the configuration will be uh, Xc again 4F0. Both are having 0 unpaired elements. And what about option B? Yb plus 2 and Lu plus 3. Yttrium plus 2. The configuration is Xc4F14. And if we consider the lutetium Lu plus 3, the configuration is again Xc4F14. Again, these two are also having 0 unpaired electrons, right? So, both A and B are diamagnetic in nature. And if we consider the remaining charges, for example, La plus 2, Plus 3 is having 0 unpaired. Plus 2 means definitely it has one unpaired electron, right? So, like this, if we check the remaining ions, all are having unpaired electrons. They are asking for the diamagnetic ions, which are having 0 unpaired electrons. The first and the second one are the correct options. The reaction sequence given below, the correct statements they are asking. First, let me write the products here. So here as a double bond is there when it is attached to the HBr, definitely we get the cyclohexyl bromide like this, right? And if it undergoes Finkelstein reaction with a sodium iodide, definitely we get iodocyclohexane here. And in the case of Schwarz reaction meant for fluorination, and in presence of AgF, it readily gives cyclohexyl fluoride, right? Cyclohexyl fluoride. So the Q is this one, and the R is this one. And what they are asking for here, they are asking about the CX bond length and bond enthalpies, right? Okay. Now, if we consider the CX bond length and bond enthalpies out there, we know already that if we consider CF bond, it is less when compared with CCl, CBr, and then CI. Bigger the size, more is the bond length. Hence, we can say that CI formation. Here, what is the product CI? That is nothing but Q, right? And here this is the P, R, sorry, R, and this is the P, right? If we compare the PQR, Q will be having the less bond enthalpy and more bond energy, right? As the size of the halogen atom is more, bond length more, whereas bond enthalpy is less. In that case, the bond enthalpy is very less for R and follows a P, then Q, right? So the CX bond enthalpy will be R greater than P greater than Q. So this is the correct statement. Regarding the bond length, no doubt Q is greater than P greater than R. But they have given QRP in the first option. So option B is the correct. And whatever the remaining options here, the relative reactivity towards the SN2 reaction is P greater than R greater than Q they have given, which is a reverse order. So option C also wrong. And what about the pKa values of the conjugate acids after leaving those PQR? pKa values, pKa value of if we consider the iodobenzene, it is a better leaving group, right? Better leaving group, which is having the lower pKa value, but they have given the higher pKa value for R, this R1. So option D also wrong. Hence the correct option is next one.
Here this is the section 3, 8th question. They have given some rules for the mass. You can check. The question is, in an electrochemical cell, dichromate ion in aqueous acidic medium are reduced to Cr plus 3. Then the current flows in 48.25 minutes is. So for dichromate ion, 2 Cr plus 3s will be reduced, right? But we know in this conversion 6 electrons are required. But for 1 mole of Cr plus 3, we require only 3 mole of electrons. That means 3 Faradays of electrons we require. We know the formula Q is equal to I into T, right? Q is equal to I into T. Here Q is 3 Faradays and time we have to mention in terms of seconds. So the current I will be 3 into 96,500 divided by that 48.25 into 60, right? So where we get answer as 100 amperes. Next one. At 25 degrees centigrade, the concentration of H plus ion they have given in the aqueous solution of a weak monobasic acid with the dissociation constant Ka, and they also mentioned that it is x into 10 to the power of minus 7 molar concentration, and they are asking us to calculate the value of x. So for this we have the formula H plus ion concentration is equal to square root of C1 into Ka1 plus Kw, and whatever the values they have given, if we substitute, you will get the answer as a 5 into 10 to the power of minus 14 under square root, where the answer is 2.23 into 10 to the power of minus 7, and x is equal to 2.23 here. So if the video is really helpful for you, please like, share and comment, and subscribe to my channel. Let's move to the remaining questions now.
Molar volume of the van der Waals gas equation can be calculated by expressing the van der Waals equation. Cubic equation, if we consider, as the Vm is variable, ratio of coefficient of Vm square to the power Vm they are asking. A value, B value, T and the pressure they have given. And let me check the van der Waals equation first. Let's write P plus A by Vm square into V minus Vm minus B is equal to R into T. So that is equal to PVm minus PB plus A by Vm minus AB by Vm square is equal to R into T. I am going to multiply the whole equation with the Vm square as the Vm cubic equation we want. So PVm cube minus PB Vm square plus A into Vm minus AB is equal to RT Vm square. Let's divide the whole equation with the P because we want the cubic equation in terms of only Vm cube. So Vm cube minus B by Vm minus B Vm square plus A by P into Vm minus AB by P minus RT by P into Vm square is equal to 0, right? So let's take the things together here. So Vm cube minus Vm square, if we the common value, we will get B plus RT by P Vm square, and here the remaining part is plus A by B into Vm, right? A by P, sorry, A by P into Vm minus AB by P is equal to 0. So in this equation, we want Vm square by Vm coefficient. Coefficient of Vm square divided by coefficient of Vm is nothing but minus of B plus RT by here what is there? P is there, right? So that's what I'm remembering here. So RT by P divided by Vm is A by P. So what we are getting here as a coefficient, as a ratio minus BP plus RT divided by A we are getting. So if we substitute all the values here along with the gas constant, you will get the answer. The answer as minus 7.01 approximately. That is the answer. Next one. Considering the ideal behavior, the expansion work done when 144 grams of water is electrolyzed completely under constant pressure at 300 Kelvin is. So when the water is electrolyzed, 2 moles of H2O, if we consider it readily electrolyzed to 2H2 plus O2. That means total 3 moles of gases will be formed. But when there is 144 grams of water, it means that 144 by 18, nothing but 8 moles of water. So for 8 moles of water, definitely we will get 4 into 3. For 2 moles it is 3, for 8 moles it is 4 into 3, nothing but 12 moles of gases will be formed, right? Expansion work done, formula E is equal to minus P delta V. Uh, V2 minus V1, if we consider, V2 will be the volume of all these 12 moles. So V2 is nothing but nRT by P. So N is nothing but 12, 8, this R is nothing but 8.3, and P is how much here? They have given as a 300 Kelvin. So 300 Kelvin by P. So substitute here in this equation minus P into 12 into 8.3 into 300 divided by P minus 0. Then how much we are getting here? In terms of minus only we will get, and P gets cancelled out, and we will get the answer as 29,000. 29,880 joules we get, but in terms of kilojoules, it will be around minus 29.88 kilojoules. So this is the correct answer. Monomer involved in the synthesis of nylon 66 gives positive carbyl element test if 10 moles of X are analyzed using the Jumas method. The amount of gas evolved are. So here if we consider this particular nylon 66, hexamethylene diamine and adipic acid are the monomers. As it is giving the carbyl element, it's a primary amine. So hexamethylene diamine, that is nothing but NH2CH2 of 6 times NH2 is the compound that gives N2, 1 mole of N2 for 1 mole of hexamethylene diamine, right? And what they're asking for here, this is nothing but X, which is involving in the synthesis of nylon 66. And for 10 moles of X, how much amount of nitrogen is formed? So for 10 moles, how much amount is formed? 10 moles again we will get. 1 mole is nothing but 28 grams N2. For 10 moles, it is 280 grams. So 280 is the answer for this question. The reaction sequence given below is carried out with 16 moles of X. The yield of major product in each step given below, the product is in parentheses. So this 100%, this 50% like that they have given. The molecular masses also they have mentioned here in 210 they have given. And the amount of S, product S they are asking. The final product mass they are asking, right? Now let us see one by one the reaction. If we consider the X here, X is nothing but Br, and here you will get that ketones. Sodium in presence of dry ether means definitely Woods reaction. And here they have given the hydrolysis also. This hydrolysis is for this particular ketol form, which converts into CHO here. It is here the aldehyde group is protected, right? So on hydrolysis again we will get back that CHO. But here they have given 16 moles. 16 moles become 8 moles of this diphenyl compound because aryl halides on Wood's reaction, we will get a biphenyls which are attached to the CHO. So this is the compound P which is formed 8 moles. And if we consider that NaOH, NaOH followed by hydrolysis, if we consider NaOH followed by hydrolysis, see these are undergo Cannizzaro reaction, right? Internal Cannizzaro reaction, if we consider inner Cannizzaro reaction, if we consider, you will get the answer compound as one is undergoing oxidation, the other is undergoing reduction, so COOH, and here you will get CH2OH, right? So this will be the compound Q. This is Q. Q on NaOH plus CaO, which is a decarboxylating agent. You will get no group here, right? So what can be the R value, R compound? This is the R compound, right? When it is treated with the PBr3, definitely alcohol will be substituted with the Br3. So here I am writing the benzene group also, and here PBr3 if we consider, you will get CH2Br. So CH2Br, and when it is treated with and percentage also we have to see, right? So let me check the percentages. So here P is 8 moles. So only 50% means 4 moles. Again only 50% means 2 moles. And here 2 moles. If we consider, you will get only 1 mole here. And with NaH, definitely we will get a methyl group in presence of CH2Br. So CH3, and as it is 1 mole, you will get zero point 0.5 moles of this compound. And if you check the molecular formula of this compound, it is around 168. Therefore, zero point 0.5 into 168, how much we are getting here? 84 grams we are getting. So 84 is the correct answer. Let's move to the question. Here, this is the second group, this third group cation, Mn plus 2 fourth group, and Ba plus 2 is fifth group cation. And if we consider the Cu plus 2, Cu plus 2, as it is a second group which is identified by means of this by means of H2S in presence of HCl, right? And if we consider the Al plus 3, NH4OH and NH4Cl. If we consider NH4 twice CO3 NH4OH, which is a fifth group reagent, Ba plus 2. And if we consider that Mn plus 2, which is a fourth group, by passing the H2S in H4OH only, we will get. So, correct option is the first one. So, the next question here, the major products obtained from the reaction. In the list are the reactants mentioned in the list 1. Match each entry in the list 1 with the appropriate entry in the list 2 and choose the correct option. So what we have to do, we have to write the products of the list 2 and we have to check uh, those products are the reactants for which name of reactions. That's what they are asking. Here in the first question in the list 2, toluene, that means on the benzene CH3 is there. So if we consider the CH3 with the CrO2 Cl2, it readily converts into benzaldehyde. So benzaldehyde, and if we consider the benzaldehyde, um, it is the name of reaction for Cannizzaro reaction, right? So this is one. Now, second one, benzoic acid on benzene COOH will be there. With PCl5 it converts into COCl. With NH3 it converts into NH CONH2 amide. And P4O10 is a dehydrating agent. So you can say that a H2 will be removed, and so that phenyl cyanide will be obtained, which is a um, reactant for the Stephen reaction. So for Stephen reaction it is 2. Now third one, nitrobenzene with Fe and HCl. On the nitrobenzene, as nitro group is there on benzene, it is converting into NH2. With HCl and NaNO2 undergoes diazotization and 2 plus Cl minus. On hydrolysis, I mean, HCl NaNO2 followed by hydrolysis only, you will get benzene diazonium chloride, which is a reactant for which reaction here? This Sand-Meyer reaction, right? So option 3. What about this Hoffman bromide? Hoffman bromide generally we get aceto. I mean, if we consider that Hoffman bromide, CO and H2, right? On benzene, CO and H2 must be there. Let's check this one. Toluene with Cl2. If we consider in presence of sunlight, means the alkyl group will be substituted as a benzol chloride, followed by hydrolysis and dehydration leads to the formation of benzaldehyde here. And in the presence of Tollens reagent, definitely it will convert into COH, and SO2Cl2 means it converts into COCl, and with NH3 again it converting into CONH2, right? So this is the reactant for Hoffman bromide reaction. So this is the fourth one. So 2341, where we get the 2341 in the option B. So match the compounds of list 1 with that of the list 2 compounds. In the first list, the compound P, if we consider, it is ninhydrin reagent where primary alpha amino acids readily give purple color with the ninhydrin reagent. So it is 2. And if we consider this one, uh, this on hydrolysis will give the ninhydrin test, and it does not give any positive test with that of the phthalate dye test. And if we consider R, coupling reaction, which gives a yellow color dye. And if we consider this one, NH and H2, where glucose readily gives hydrazone, right? So this is the third one. So 2513 is the correct matching. So answer is B. That is all for the paper 1 advanced 2025.